Hello, Algebra 1 students, and welcome back to Topic 3, Linear Functions. Last class, you guys were reintroduced to the idea of what is a function, along with the concepts of domain and range. That was probably new to you this year. And just some various properties of what makes something a function. Today, we're going to take that a step further, and we're going to talk about some very important notation called function notation. Now, it's kind of a silly name because as you get up into higher mathematics, you'll find that this notation can be used for equations that are not functions. But for now, we're just going to see it used in the concept of functions. Apologize, my dog is drinking water very loudly right behind me. He does this on purpose, I'm sure. So let's go ahead and work with an equation on the opener. Let's work with the equation y equals 3x plus 1. So there's 6 questions here, and if you have the time, you should definitely pause me and fill these out. They are review from the last couple lessons as well, but they're really going to lead us into the main concept of today. But if you don't have the time, you can let me keep playing, and we'll start with A. So A says, let x equal 7. What is the value of y? If you wanted to think of this in terms of a coordinate point on a graph, what they're telling us here is they're telling us the x value is 7. That was supposed to be not a highlighter, is 7. And they're interested in what is the y value that is mapped or corresponds or is created by an x of 7. Well, to do that, we take our equation, y equals 3x plus 1, and we substitute in the known value. In this case, the value we know is an x of 7. That's what was given to us. And they're asking us for the value of y. Now, you might think I'm a little crazy if I said, here's the value of y. It's 3 times 7 plus 1. Technically, that is a number, 3 times 7 plus 1. But I think most people would prefer if we simplify this to get to that number. Now, as we go through and simplify, we should be asking ourselves, are we following PEMDAS or SADMAP? Because it's very easy to get confused to know which one to use. PEMDAS is always used to simplify one side of an equal sign. So ask yourself, are we trying to simplify this side? Yeah, we are. We're trying to simplify that down into a specific number. So we do need to follow PEMDAS here. Now, as you follow PEMDAS, hopefully at this point in your career, you realize that there's nothing actually happening inside the parentheses to the 7, so the parentheses are kind of extra. There's a 3 that's multiplying by 7 and a 1 that's adding, right? We could even see that up here. There's a 3 that is multiplying and a 1 that is adding. And in PEMDAS, we do multiplication ahead of addition, so we multiply our 3 times 7 to get 21. And then we finish off by adding those together to come up with 22. Okay? Now, as we look at that, we should know a couple things. First, we have answered the question. What is the value of y? The value of y is 22. We could also write this more concisely as a point, 7 comma 22. We learned last class that we had an input of 7, and that gave us an output of 22. And we now have enough knowledge to answer part B, where part B said, do we follow PEMDAS or SADMAP? We talked about PEMDAS. And it also asked, could we have used a calculator for this? And the answer is yes, a calculator should be capable of typing in one entire side of an expression as long as there's no variables, no x's or y's, hitting enter and coming up with the answer. So whenever you're doing PEMDAS, yes, you can use a calculator. All right, let's see how that contrasts with C. Part C says, let y equal 7. What's the value of x? So again, we start with our y equals 3 times x plus 1. But in this case, we're not replacing the x with 7. They told us the y is 7. So we should take this equation and replace the y with 7, like so. Now, when we do that, then the question is, what's the value of x? That means our answer better say x equals something, and it doesn't right now. The first question we always ask, is x isolated? But if you look on the right side of the equal sign where the x is not isolated. And if it's not isolated, we need to solve for x. Solving for a variable is always SADMAP. But the nice part is, the two numbers that are attached are the same as before. It is a 3 and a 1. In SADMAP, what do we undo first? Well, we undo addition ahead of multiplication. So let's subtract our 1 from each side. Okay. We end up with 6 equals 3x. And then we finish off the division, though I would hope you could ask yourself 3 times what is 6, and you say, oh, that's 2. But of course, we could also divide by 3 to get the 2 as well. So what did we do here? Well, this one was kind of backwards. For this one, they gave us the output, or the y value of 7, and we had to work backwards to find the input of 2. Now, if you substitute 2 in here and do the math, guess what you'll get as an answer? Well, 7, of course. Did you follow PEMDAS or SADMEP? We covered that we followed SADMEP. And could you use a calculator? And the answer is not really. I mean, you can always use a calculator for basic math, but we cannot type this into a calculator. And so at least in Algebra 1, we need to know, don't type x in your calculator. Some calculators even have an X button. It's not what you want in Algebra 1. Don't type X in your calculator. Calculators only simplify numbers in Algebra 1. Okay, let's look at our last two. The input to y equals 3x plus 1, might as well write that one more time, is 10. What's the output? Okay, well, the input is 10. Do we remember what inputs are? You should probably notate this on your paper. The input, if it's not told differently, is the x value. They're saying what's the output? That's the y value. So they are actually telling us here that the x value is 10. So they've told us this is 10. They want to know what is the output, what is the y? Well, we multiply first, add after, and the y value is 31. Or another way to put that is we input 10 and we got an output of 31. Last one. The output to y equals 3x plus 1 is 10. What's the input? Okay, well now they've given us the output. The output is the y value, and they're asking us what is the x value. So let's take a peek. The output is 10. We do not know the x. We don't know the input. But it's the same steps in SADMEP as we did on part C. We're going to subtract 1 from each side. That leaves us with 9 equals 3 times x. Divide off the 3. And it leaves me with 3 is equal to x. Another way to phrase this is if you were to input 3 in for the x, the output or answer would be 10. Okay, so there's our introduction. Now we're actually going to get to the main part of the lesson, which is going to continue to use this y equals 3x plus 1, right? We always try to tie the opener into the rest of the lesson. So today we're going to discuss the concept of function notation. There we go. I like to think of this idea as naming formulas. You literally get to pick any name you want. You're like, I'm going to name this formula Bandit. I'm going to name this one Cow. Right? Whatever sounds good to you. So for example, in the opener, we had the formula multiply x by 3 and then add 1 to find the output. Now, of course, on the opener, we wrote it as y equals 3x plus 1 because that's a lot easier to say than this whole sentence. But we also used y equals 3x plus 1 over and over and over on this. So what if instead of saying we're using y equals 3x plus 1, we just said we're going to use the formula that we named something. Again, maybe we named this formula giraffe. And then you go through and you just say, use the giraffe formula every time. Well, you know what you were talking about because you'd have defined this as the giraffe formula. Now I'm going to be a little less creative down here, and I'm going to go ahead and name the same formula math. So that's the name of my formula. So anytime I say I want you to use the formula called math, we're going to use the formula 3x plus 1. Now there is a specific way that we write this in math. Math and math. So the first thing we need to do is we need to start with the name of the function. So this math right here, this is the name of my function. And then directly after that, we need to tell the person reading your formula what variable are we using for the input in our function. And the input we saw up above was the x value. So we have math of x. So we're saying we have a formula called math. We're going to input numbers into the x variable, and it will give us an answer. Now, originally, we also have to tell them what the math formula is. So we say the formula called math, where you plug x's in, is going to be 3 times x plus 1. So you'll notice that there is another input on this other side. We have an input originally, and then we actually use the input in the formula. And by the way, you might have caught me reading this name, and it might have been a little bit weird to you. So when we see this math parentheses x, we don't say math parentheses x, and it is also one of the only times that there is no multiplication. So I put a little dot there. I'm going to take it away. There is no multiplication there. This is a naming syntax. It's a way to name formulas in math, and there is no actual multiplication. We read this as math of x equals 3x plus 1. So this whole part I'm highlighting in green, math of x, this is math of x like this. All right? So when we look at this, we say math of x, we don't say math parentheses x, and we definitely don't say math times x. There's no multiplication there. It's just how we name formulas. Now, last but not least, we've of course seen the formula y equals 3x plus 1 like 20 times on this page. So instead of writing math of x equals 3x plus 1, we certainly, instead of saying math of x, could just write y equals 3x plus 1. Anytime you use function notation, if you don't want to use the name and you just want to use the standard y as your output variable, that's fine. But it's important to realize that the y is the same thing as math of x. Oftentimes, you'll even see this as let y, so let the output be created using the formula math of x, meaning they'll give you an input, you put it into the formula, do some math, and you'll find the output. Now, let's actually see why you might want to use this and get some specific examples instead of me naming formulas weird things. So here we go. Oops, and it's going to zoom out. One day, OneNote will fix that feature, but today is not that day. Let y equal 3x plus 1. This is A. Find y when x equals negative 1. All right, this is just like the opener. X is negative 1. So let's go ahead and replace x with negative 1. We do that here. And then we multiply. That gives me negative 3. And we combine negative 3 plus 1 is negative 2. So we made the point when x is negative 1, the output was negative 2. Okay. Let's look at B. B says, let math of x equal 3x plus 1. Find math of negative 1. So we're actually going to have to do a little bit of writing here. You'll need a few lines. You'll probably want to write kind of small. So we're going to say math of negative 1 means. So what this means is we want to input negative 1 into the formula called math. So if we look at this, math of x, and they said we're going to find math of negative 1. Well, that means we want to input negative 1 into whatever formula math is named after. So let's try it. We're going to find math of negative 1. Now, we know what the math formula is equal to. The math formula is equal to 3 times x plus 1. But they have now given us a different number than just x, right? They've replaced x with negative 1. So when they say find math of negative 1, we say, oh, cool. Let's input negative 1 into the 3x plus 1 formula and simplify it. So math of negative 1 is going to be equal to whatever 3 times negative 3 plus 1 is, which we just did over on the other side. It's the same exact problem. It is negative 2. So math of negative 1, when we substitute negative 1 into our math formula, the output is negative 2. Another way to write this is we found negative 1 was inputted, negative 2 was outputted. Right? It's the same answer that we got on the other side. It's just phrased a different way. Now, once you've defined the formula with the name math, you can use it many times. You can say find math of 70, find math of -6, and you don't have to keep writing the formula. So it's a really effective way to communicate something, especially if we have problems with more than one formula. Let's say you had something with 3 formulas and you had Anthony, Betty, and Chase working with you. And you had a formula y equals 3x plus 1, y equals 4x plus 1, and y equals 5x plus 1. You're like, Anthony, I want you to take y equals 3x plus 1. Betty, I want you to take y equals 4x plus 1. Chase, I want you to take y equals 5x plus 1. That's fine. You can communicate that. But if you had named them, it's a little bit easier. You could say, Anthony, take the equation called math. Betty, take the equation called function. And Chase, take the equation called cow. And that's a really easy way to narrow in on the right equation instead of just seeing a sea of y's and x's. So let's try one more time. But instead of calling our formula math, we're going to use the most common letter that people use for formulas. Instead of using a full name, mathematicians try to be as efficient as possible, and they usually just use a letter. And the most common letter they use for the name of our formula is F. Now, sometimes people say F stands for function. It's kind of true, but I actually prefer to say that F stands for formula. So if we look down below and it says let f of x equal 2 times the quantity x minus 1, what we have here is we have the name of our formula. The name of this formula is the boring letter F. Okay, and then of course we have the input. So when they ask us to do things here, they're going to give us a number for x, and you're going to have to substitute it into the formula called f. Now where is the formula called f? That's over here, right? This is my formula. So as we look at this, they say find the value of f of 0. Well, we know the overall formula f of x is equal to 2 times x minus 1, and they want us to find f of 0. Okay, to do that, we are going to go through and we're going to replace the x, the input, with 0. F of 0 means put 0 into my formula. So f of 0, the answer when 0 is put in is going to be 2, let's do the parentheses first, 2 times -1, and 2 times -1 is -2. So f of 0 is -2. And again, another way to write that answer is 0, comma, -2. And I keep writing this coordinate notation because we're going to need it to end class today. And so it's nice to see the connection of f of 0 equals -2 means 0, comma, -2. Okay. There are 2 more here. I imagine you guys can do these without me, but if you want to listen to me drone on, keep letting me talk, totally fine. Otherwise, pause me, find the answers, skip, make sure you got it right, move on to that next section. So we're going to take a look at f of -2 this time, which means take -2 and substitute it into the function or into the equation or the formula that's defined by f. And our formula is 2 times an input minus 1. The input they gave us here was -2. So we are finding the answer to our formula evaluated at -2. Do the parentheses first, and that gives us -6. Or in coordinate form, -2, comma, -6, right? F of -2, the answer to the formula when 2 is input, is -6. Let's find f of 5. Okay, f of 5, same idea. We are inputting 5 into our formula. And 5 minus 1 is 4, and usually 2 times 4 is 8. Lovely. Okay, at this point in time, notice how efficient this notation was. They just said evaluate f of 5, and that told us to plug 5 into this formula and simplify it and find the answer, right? 5, comma, 8. So let's look at where function notation can get a little bit tricky. We're going to compare the following 2 examples using a new formula, g of x equals -2x plus 4. So my new formula's name is now g. And you will find that math typically starts with f, and if they've already named an equation f, then they'll go on to g, and then sometimes h. Okay? So example 1 says find the value of g of 2. If you're asked to find g of 2, then that means, right, if we take a look at our formula here, that 2 is the input. When we input numbers, we input them in for the x variable unless they tell us something different. So I'm going to input 2 into my x variable, and we want to find the output. So g of 2 will be negative 4 plus 4, and negative 4 plus 4 is 0. So we have found that when you input 2 into my formula, we get an output of 0. Or you could think of it as the point 2, 0. Now, I said this gets tricky. This seems pretty straightforward. It's what we've been doing. But let's look at the second example. The second example says, find the value of x such that g of x equals 2. Now, this is already different because if you look at this formula, we do not have an input. We don't have an x value. The problem tells us to find x, which means in this problem, we do not know the input. What I see many students do here, and I'm going to cross it off in a second, as soon as they see x and 2, they automatically say, oh, we want to find g of 2 in this negative 2x plus 4, so that means I'm going to substitute 2 into our equation. However, that's not what they're telling you here. We just found g of 2. g of 2 was 0. What they're telling us is they want to find g of what equals 2. Right? G of 2 equals 0 doesn't work. We didn't find an answer, and that's the key here. We didn't find an answer of 2. We found an answer of 0. So this is not what we want to do. So another way to phrase the question is, what value of x can I put in here where when I do this whole formula, the answer becomes 2? And luckily, we're in algebra. One of the biggest points of being able to do algebra is if you're asked the question, what number can you put into an equation to get an answer, you're now able to solve that. The way you do it is you take your formula and you set your formula equal to the answer you're trying to find. This 2 is an output. They're saying, what is the input that gives us a 2 as an output? So, how do we do that? Well, this is really the point of algebra. 2 equals negative 2x plus 4. Well, guess what? We're trying to find x. Is x isolated? No, we just use SADMEP here. And so this is pretty common for function notation. Sometimes you use PEMDAS, just like the opener, but other times you'll have to use SADMEP because they'll have given you the output and they're asking you for the input. So let's rock and roll. Let's undo adding 4 first. This leaves us with negative 2 equals negative 2x. And then we'll undo the multiplication by dividing by negative 2. Anything divided by itself is 1, which is useful because that means that the other side is 1 as well. So what did we find here? We found that if you had an output of 2, in order to create that using this formula, the input had to be 1. This does get a little confusing. I understand that. However, we're going to practice this a bunch for the rest of class. So let's move on to our third page and let's try a few. On A, we have let f of x equal 3x minus 12. Find the x which causes f of x to equal 9. So the way I think about this is we're looking for an x such that when you put it into our formula, the answer is 9. So another way to think about it is we don't know the x, right? They told us find the x. If we don't know the x, what must we know? Well, we certainly know the y, or the output. So another way to phrase this is we have the equation, or the formula 3x minus 12. They're looking for an x such that when you put it in, the answer becomes 9. So as you look at it that way, hopefully we can realize that this is another case of SADMEP. And we're going to go through and undo our subtraction first, and then our multiplication. So let's undo the subtraction, like so. Leaves us with 3x equals 21. And then, of course, we'll divide off the 3. And by the way, 21 divided by 3, I just had this on my last test, is not 3. I felt bad for the student. They did everything right till the very end. 21 divided by 3 is actually 7. And so what we found here is we found that if 7 were the input, 9 would be the output. Okay, let's look at B. Find x when y of x equals 3. So this is a weird one. We have the name of our formula this time, right? The name is y. And they said find the x. So we certainly do not know the x value. However, they've told us that when you input the x into our formula, the answer or the output must be 3. So the question becomes, what x turns this formula into an answer of 3? Well, that's great because now we can use our awesome algebra skills to solve. We just have to work through SADMAP here. Okay, I see two numbers attached to x. A 3 is dividing. A 4 is adding. Let's undo the addition first. Leaves me with x divided by 3 equals -1. And then we undo division. You may have forgotten fractions, fancy way to write division, right? We undo that by multiplying by 3. Because when you have 3 divided by 3, anything divided by itself makes 1. We don't need to write that. And it leaves us with -3. So again, interpreting this answer, we started with an output of +3. And we found if you had an input of -3, it would create that output of +3. Let's look at the last one. Given grant of x, so we again have the name. This is a more complicated sounding name. Grant of x equals -x minus 1. Find grant of -5. So my answer is going to say grant of -5 equals something. Now think back to what we did on the previous page. Grant of x, they replaced the x with -5. Which means -5 is actually the input, right? It is what x is equal to. So in this case, we know what to input and we're looking for the output. So grant of -5 is going to be equal to, and we're going to replace the x. We know the input this time, unlike the other two. So notice I kept the negative, parentheses for the x, -1, and we're going to replace the x with -5. Now the nice part is grant of -5 is already isolated. We're not going to do things to both sides here. Grant of -5 is equal to whatever this equals. And you could use a calculator, but I think the math is not too terrible, right? We have two negatives, which we know become a positive, which we don't actually have to write. And then we just bring down the -1. Okay? And we have 5 minus 1, which is 4. So in this case, grant of -5 is 4. Or another way to think about that is this is the point -5, 4. Now, I have some bad news for you. We've actually done more algebra up to this point than we'll do for the entirety of the rest of the lesson. In fact, I would argue that for the rest of this lesson, we really won't have to do any arithmetic, adding or subtracting, any PEMDAS or SADMAP. The rest of this lesson is just going to be, how does function notation apply to other circumstances? In math, we always try to look through the view of 4 different styles of mathematics problems. The first and maybe most common in algebra is if you're given an equation, can you use that concept? And I'm pretty confident that by now you can use function notation. The second is if you're given information in a table, can you use the concept? So we're going to do function notation in a table. The third is if you're given a graph, so we'll practice function notation with a graph. And the one we won't get to today, but we will cover over the next 2 classes, is how can you use function notation with word problems or real-world situations. So if you need a quick breather, take it, but this last part of the lesson, example 3 and example 4, go pretty quickly. All right, let's read through example 3 carefully. The table below displays selected values of the relation y equals g of x. Okay, selected values. Let's get into that in a second. However, we do not know the actual formula that is called g. Before answering any questions, label the inputs and outputs in the table below. So let's break this down. The idea behind this is that we have some function where the y's are going to be the outputs and the x's are going to be the inputs. So there's a few things to get out of here. The x's, of course, are the inputs. So they asked us to label this. Let's do that right now. The x's are the inputs. We also need to realize that instead of calling our formula g of x, we can certainly call it y, which makes the second row the outputs. Now, how is this table created? Well, it's actually an unknown formula. So what they may have done is they may have had a formula like g of x equals 7x minus 2, and they may have just taken all of these x values, like 2, input it into the formula. So that'd be like finding g of 2. 7 times 2 minus 2, that's 14 minus 2, that's 12. So they input 2 into the formula, they found 12, and then they would put 12 into the output. Now, the output here, of course, is negative 2, so I did not pick the right formula. This was a random formula. But the point of this is they did all the math for us using an unknown formula. So I don't know what they plugged 2 into, but they did math to it, and at the very end, they got an answer of negative 2. So as we go through and use this table, let's see if we can understand how function notation applies. A says, what is the value of g of 2? Now, as a reminder, g of 2 would normally mean we have some formula that's doing math to 2, right? It's doing math and doing more math over here. We don't know what's happening. But one thing we do know is that 2 is the input, and I'm going to keep writing it in parentheses. 2 is the input. So to find g of 2, we need to go to the input row. G of 2 means we input 2. Where is 2? Oh, it's over here at the very end, of course. We input 2 into our formula. And what is the output? Another way to think of this is we are doing g of the x value, and g of 2 will give us negative 2. So when you input 2 into our formula, the output is negative 2. Okay, let's try the next one. When g of x equals 2, what is the value of x? So right away, they said, what's the value of x? Where are your x values? They're at the top. They don't know which x value it is, but it's going to be one of the 5 of those. They told us that g of this unknown x value gives you an output of 2, an answer of 2. So essentially here they're saying we know the y, we want the x. So let's look at the y's. Where is there a y of 2? Oh, right here. That's fine. And so what is the x? The x is negative 3. So x is negative 3 because according to this table, g of negative 3 is 2. So this is the answer we're looking for. C says, find the value of g of negative 3. All right, well, let's see. G of negative 3. Negative 3 is the input this time. So let's look at the row with inputs. That's my top row. Whereas negative 3, oh, it's right here. And so the input is negative 3. What does that make the output? Certainly 2. D. What value of x causes g of x to equal negative 1? So we don't know the x. So g of something equals negative 1. So this is our output. We go to the output row. We head over to negative 1. There it is. What is the input that created that? That input is 0. So what value of x? X equals 0 created an output of negative 1. Now, these last two are just review from 3.1. It's always important to cycle back to what we've learned before so that we don't forget it. Write the domain and range. Hopefully remember the domain is just a list of all the inputs. We like to arrange them from least to greatest, and luckily they already are arranged from least to greatest. Negative 3, negative 1. There are 2 zeros. We're just going to write one of them. 0 is the same number. Don't need to put it twice. 2. And then we write the range. The range didn't go from least to greatest, I'm not going to dock any points if you don't do it, but it is considered pretty typical to arrange from least to greatest, just so we can kind of think about a number line here. Good. Is y equal g of x a function? How do you know? Well, functions are all about the property that if I give you an input, you can tell me what the output is. So let's play a game. If I give you an input of -1, can you tell me what the output is? And I would hope so. An input of -1, the output is 1. All right, let's play again. If I give you an input of 0, what is the output? Do you see the issue? There are two different inputs of 0 with two different outputs. This is like walking into a restaurant and two people ordering the same entree but being charged two different prices. That doesn't make sense. If you pick an input, you need to know what is the output that goes with it. So the output that goes with this are both 0 or is it -1, right? There are two. And that uncertainty means that this is not a function, right? Not a function. Most of the time, people would say the input of 0 repeats. You could also say that 0 maps to two different outputs, something like that. All right, last page. As mentioned, this last page has a graph. On this graph, we're going to go through and start by labeling every integer or nice point in x, y notation. Right, and I'll just start on the bottom right. This is the point 4, -1. I also have the point 2, 0, 0, 1, -2, 2, and finally this open circle we'll talk about later, -4, 3. I'll move this off just so we can see it. -2, 2. There we go. All right. Now, we listed these points as x, y. But really, points are listed as input, output. This is what we substitute in. This is what we get back out. Of course, in most notations, we see that as x, y. The really observant of you, though, will have noticed that we still have our x or input axis over here. But instead of a y-axis, now we have an f of x axis, where f of x means you're applying a formula to x. Now, is it the same as y? Yes. Is it still the outputs? Yes. It's just a different name. Now, sometimes to cut down on the math, instead of actually finding the y value, sometimes people write points as the x value, and then they'll just say the y value is whatever the x equals when it's substituted into our formula. So let's see what that looks like just using the point 0, 1 up above. It is totally okay to write the point as 0, 1. But if you hadn't found that 1 yet, sometimes you would see people say the x coordinate is 0 and the y coordinate is whatever you get when you substitute 0 into your formula. So 0, f of 0. Another way to write this is you can actually say that f of 0 is 1, and that is because we have the point 0, 1. So what I'm going to teach you at the end of this lesson, which is right now, is if you are given an input or an output, how do you find the other one using a graph? And it's very similar to what we did over here, right? We found an input, we looked at the input to find the output. And so we're going to do the same thing here. But what we need to remember is that the inputs are along the x-axis and the outputs are along the y-axis. Now the x-axis is of course horizontal and the y-axis is vertical, and that's going to become very important, well, right now. So let's take a look. Use the graph of y equals f of x above to complete each question. So they want you to find the value of f of -2. Now if you knew the formula, if you knew what f of x actually equaled, then you would take -2, you'd put it in the formula, you'd put it in the formula, do some math to it, and it would give you an answer. But we don't know the formula. but we know the picture that the formula makes, because that's what a graph really is. It's a picture of all of the inputs and outputs of whatever formula made it. In this case, our picture is a line. So our formula created a line. So when they say find the value of f of negative 2, what they really mean is that negative 2 is being input into a formula. And if it's being input, that means that is an x value. So what we're going to do is we're going to go up to the graph and we're going to look along the x-axis for negative 2. So let's go up here. My x-axis at negative 2 is right here. Now our goal is to figure out what is the y value. Now the y value, there are lots of y values here. For example, there's the y value of negative 4. But if I combine negative 2 and negative 4, I get a point right here. In order to get a point that was created using this formula, the point right here needs to be on my line. So another way to phrase this question is there a point on this line with an x of negative 2? And certainly there is. We can see the point right above has an x of negative 2. Now, if you didn't have that point labeled and you wanted a nice shortcut to this, you don't have to label all your points. All we do is we go to the x-axis and then we move up and down to match to the graph. I certainly wouldn't want to move down, there's no graph there, but I'd move up and say, ha, I found a point on the graph. What is the y value? And the y value is, of course, 2. So because there is the point negative 2 comma 2 on our graph, then we know that f of negative 2 was 2. Negative 2 put into this mystery formula made an answer of positive 2. So I'm going to quickly erase the rest of my points, even though you can keep them there if you'd like. But I think this kind of clean picture will give us a better idea of what we're trying to do here. If you already labeled yours, keep them. That's fine. So complete the point 4 comma f of 4. Well, we already know 4. That's given to us. We want to know, though, what is the output when you substitute 4 into this invisible formula. So let's find 4 on the x-axis, right? That's our horizontal axis. Let's see, 4 is right here. And then ask ourselves, is any point on this line have an x value of 4? And the easiest way to do it is to say x is 4. We go down to find the graph. And what is the y value that corresponds? That's negative 1. And of course, this is the point 4 comma negative 1. So we know since 4 negative 1 is on the graph, then f of 4 created the output negative 1. Let's look at a couple more. What value of x causes f of x to equal 1? So they're saying we're inputting an x into our formula and we're getting an output of 1. So if 1 is the output, then what they've told us here is the y value, and they want the x. So in order to find this one, what I'm actually going to do here is I'm going to go on the y-axis to 1. And go over to the y-axis of 1 and say, is there a point on our graph that has a y of 1? Now with the x, we went up and down to the graph. If you're given the y, you want to go left or right. This one's kind of tricky because it's actually just right here. So we had 1 over, and then if we go down, what is that x value? That's an x value of 0. This is the point 0 comma 1. So another way to phrase this is that x is 0 because 0 comma 1 is on the graph. That means that if you input 0 into our mystery formula, the output is 1. And another. What value of x causes f of x to equal 0? So again, we don't know the x, but they gave us the output, which is 0. Okay, so let's find the x. So the first thing we do is we go to 0 on the y-axis, which is the same as 0 on the x-axis, and I'll clean this up for us right now. 0 on the x and 0 on the y meet at the origin. Okay, so we're right here. And then the question is, what's the x that's on here? So we go left and right here. There's no graph to the left, but we do go to the right, and it looks to me like we have a point 2 comma 0. Is the y value 0? Yes. What was the x that made 0? That's an x of 2. So 2 zeros on the graph, which means that f of 2 is 0. Last but not least, let's find the value of f of negative 4. So f of negative 4 means we input or have an x of negative 4, and we're looking for the output. So same strategy as before. We go to negative 4. And then we say, what's the output? So I'm going to go up because the y-axis goes up and down, and then say, looks like the output is 3. This is the point, -4, 3. So you'd say, I know this. -4, 3, so f of -4 is 3. But if you did this on a test, you would actually get that wrong. That's not the right answer. Because, and I bet you recognize this, this is an open circle. And we've seen open circles a few times, most recently in our last lesson, 3.1. But we need to remember that an open circle isn't actually a point, right? What this graph is really saying, if you drew it, and I'll just draw one right above it to show you, right? It's saying that the graph doesn't actually get there, and so technically there's no point there. It actually stops just before. So when they're saying what is there at -4, there is nothing there. Now the reason they put the circle is it's really hard to stop a line right before a point, so they just put that and say it stops right before that point. So remember, an open circle is just empty space. There is no point there at all. So is there anywhere at -4 where we run into the graph? And I'd argue there is not. So what's the answer to f of -4? Well, we would say f of -4 dne, or does not exist. There's no point there. So with that being said, I think, or I hope, that you're feeling pretty comfortable with function notation. We now know how to use function notation if you have a graph to find inputs and outputs, if you have a table, how to find inputs and outputs, and of course, if you have an equation, how to find inputs and outputs. Function notation is something you already know how to do. We didn't learn any new algebra here. We just learned a new convention, a new naming convention. It is used across the board in all of math for the rest of math. You're going to see so many f of x equations that, in fact, we're going to stop putting y's on the top of our graph and just put f of x. But in a pinch, if you don't like f of x, you can always write y. Thanks for hanging out with me. Hopefully this was a good video for you, and I will catch you on 3.3.